going to discuss circular convolution. Okay. Before we do that, let us see what is. Suppose there are two signals, x1 n and x2 n, and let us suppose their DFT is fk1 x1k x1k is summation of n changing 0 to 1 n minus 1 xn e raised to power minus j 2 pi by n nk. This will be x1k, and x2k will be summation n changing 0 to n minus 1. ये x1n है, इधर आ जाएगा x2n e raised to power minus j 2 pi by n nk. Okay, so this will be x1k and x2k. Let us suppose there are two signals, x1n and x2n, and their values are like this. When these two get multiplied, what will be the signal? Let us suppose that signal is x3k. So what is x3k? x3k is x1k into x2k, and that can be written as that can be written as 1 by n summation of that can be written as product of these two. Let me copy from here. This thing multiplied by this summation. Okay, so product of these two. Okay, since we are index, let us suppose we change the index to L. Let us change the index to L because these are dummy variables. N is dummy variable, it can be changed to anything. So I am changing it to L to distinguish between N and L, where L is also an integer. Okay, like this. Now what will be x3n? x3n क्या होगा? x3n will be inverse of x3k. IDFT, inverse DFT, and inverse DFT is performed on the summation k changing 0 to n minus 1 x3k e raised to power j 2 pi n nk. ठीक है, this will be x3k. So if we substitute this value to this value, to this equation x3k, then what will be x3k? x3k will be 1 by n summation and k changing 0 to n minus 1 and bracket start summation n changing 0 to n minus 1 x1n e raised to power minus j 2 pi by n nk. Okay, this will be first thing. Second expression will be n changing, L changing 0 to n minus 1 x to L e raised to power minus j 2 pi by n lk. Okay, this will be this, and of course because this is your x3k एंड इस समेशन के साथ में एक आएगा एक्सप्रेशन e raised to power j 2 pi by n into km. Let us say this summation is performed on m. Sorry, not this one, this one. Okay. अगर यहाँ पे हम m ले रहे हैं then it will be m x3m. ठीक है, x3m. If we write these together then x3m can be written as equal to 1 by n summation n changing 0 to n minus 1 x1n, okay, and then summation L changing 0 to n minus 1 x2L summation k changing 0 to n minus 1 e raised to power. We have combined all the exponential terms together so that we get e raised to power j 2 pi by n, k is common, m minus n minus l. Okay, we get this. Okay, now what will be this sum? This sum will be, because what is this? This is finite sum of a GP. This is finite sum of a GP, and GP का sum होता है if we have to add, let us suppose k0 to n minus 1 total n terms of a raised to power k, then it is equal to n when a is equal to 1, and it is 1 minus a raised to power n by 1 minus a if a is not equal to sum of a GP. Okay, sum of a GP. So for this thing a is basically, what is a is e raised to power j 2 pi by n k m minus n minus l. Okay, now you can observe that a is equal to 1 when m minus n minus l is a multiplier of n, capital. मतलब कि अगर suppose ये जो thing है m minus n minus l. If it is a multiplier of n, multiplier of n means n is an integer, number of terms, into its integer multiple. If it is n, then this n and n get cancelled, and it will be e raised to power 2 pi k, and value of e raised to power 2 pi k is 1. Value of e raised to power 2 pi k is 1. Okay, value of a raised to power 2 pi k is 1, so that a raised to power n is a raised to power n is 1 for any value of 1. So this will reduce to, this sum will reduce to what? This sum will reduce to this sum. If a is, अगर a की value ये put करेंगे, then this sum will be n and 0. If L is equal to m minus n plus p, p is another multiple of n, p minus n into l. L की value इससे निकालिए, n, it is a p, p could be any integer, multiple of n, m minus n minus l is np, np, n is number of terms and p is any integer multiple, so multiplier, so np, so l will be m minus n pn, okay, and 0 otherwise, 0 otherwise. Okay, now how to write this? This L index is written as m minus n plus pn, where p, all of them are integer, but it has a significance that this n is number of terms. Okay, this n is number of terms, and this L can be written as m minus n within 2 brackets like this, and with this suffix n, subscript as n. Okay, subscript as n, we can write it like this. Okay, we can write it like this, so that if we substitute this into this expression, we will get it to be x3m can be written as summation n changing 0 to n minus 1, 0 to n minus 1, x1n, and x2, this thing, m minus n, okay, where m is n, of course it is an integer which is changing from 0 to n minus 1, 0 to n minus 1. Okay, and this is what we call the, this is same as the convolution sum. This is same as the convolution sum. Therefore, this expression is called circular convolution, and it is represented by this thing, x1n. Circular convolution is different than linear convolution. Therefore, it has notation like this, x2n. This is circular convolution, and circular convolution means कि if in n domain 2 signals are multiplying, in n domain 2 signals are convolving circularly, then their DFT will be multiplying together.